Good day, everybody. I'd like to welcome you all to today's webinar. We will be discussing part 2 out of our 3-part series, which will be focusing on Fronius product and solutions. So this is what we consider our part 2 of 3 for our level 1 training. I'd like to introduce you to the training team for today. I am Mohammed Sidat. I'm the Technical Sales Advisor for Southern Africa. And I am from the subsidiary called Fronius South Africa. Okay, so we are based in Johannesburg. And I'd also like to welcome my colleague, David Mwangi, who is the Technical Sales Advisor for Eastern Africa. And he is from Fronius International. So if you joined us for part 1 out of the 3-part series, part 1 did focus on the Fronius product and solutions, and it did cover the snap inverter series. Today we will be discussing part 2, which will give a core focus to the monitoring options. And next week Thursday we will be covering part 3, which will give a focus on the hybrid and off-grid solutions from Fronius. Today's agenda, we will start off with the Fronius Smart Meter, and we will then move on to the Fronius Sensor Card, cover the Fronius Datamanager, which is our communication card. We will then have a look at the Fronius internal communication, which is called Solar.web. We will then also have a look at energy management using Fronius snap inverters. We will then move to the Fronius Solarweb, which is our monitoring platform, and then discuss the Fronius Solar Configurator, which is our design tool. And we'll also show you why Fronius has market-leading support for the industry. After which we will be having a 10-minute Q&A session where we will make sure that everybody's questions that are asked in this webinar will be attended to. We shall start off with the Fronius Smart Meter. The core function of the Fronius Smart Meter is to do energy profiling, and this is to give an overview of consumption and production. It also provides the basic data for analysis, and it also provides an online visualization of the entire system. With the Fronius Smart Meter, we have the old version, okay, which was the Fronius Smart Meter that was on the market. This old version will now be replaced by the new Fronius Smart Meter, which I will be showing you a bit later in the presentation. So I think what's important to note is that if you are buying a Fronius Smart Meter, you could be buying the old version or you could be buying the new version, depending on what your local distributor has in stock. The two versions are very similar to each other, but we will discuss the very slight differences that exist between the old and the new Smart Meter. With the old Fronius Smart Meter series, we had 3 smart meters. We have a 63 amp single-phase smart meter. We have a 63 amp 3-phase smart meter, which is mainly targeted towards residential use. And we also have the big 50 kilo amp 3-phase smart meter, which was mainly targeted towards commercial use. And another additional feature of the 50 kilo amp smart meter is the need to actually buy external CTs. So with the single-phase 63 amp smart meter and the 3-phase 63 amp smart meter, there's no need for external CTs. You only do need to get external CTs when you use the 50 kilo amp smart meter. We will now be moving on to the Fronius Smart Meter TS, which is basically our new smart meter for the market. With the Fronius Smart Meter TS, it provides the basis for Fronius Solarweb. It allows analysis and visualization of consumption data. It's the key for monitoring and efficient energy flow control. So you can basically see what's going per phase. And it also is a bidirectional meter. So you can basically measure what's going to the grid and what's coming from the grid. So basically it can give you consumption and production data. Okay, all the information from Solarweb is sent to our, all the information from the smart meter is sent to our data manager, which is found in the Fronius inverter. The data manager then sends all the data to our server in Austria, of which you can then obtain the data from Solar.web. For the new smart meter, which is called the Fronius Smart Meter TS, we have 3 variants as well. We have the single phase 100 amp variant. Okay, this is mainly for residential systems for a maximum phase current of 100 amps. Okay, it's single phase, and your AC cable cross section can be from 1 to 16 millimeters squared. With the 3-phase residential smart meter, that's rated at 65 amps. Okay. And the AC cable cross section is from 1 to 16 millimeters squared. Okay, we then have the bigger 3-phase 5 kiloamp smart meter. This is targeted towards commercial use. It's a 3-phase smart meter. It has external current sensors. Okay, and your AC cable cross section can vary from between 0.05 to 4 millimeters squared per phase. So what's the main differences between the old Fronius Smart Meter and the new Fronius Smart Meter TS? Okay, so with the Fronius Smart Meter, a termination resistor is required. Okay, with the Smart Meter TS, the easy set of termination is done via cable. Okay, for the old Smart Meter, your connections L1 to L3, the in and out are at the bottom. With the new Smart Meter, the connections for L1 to L3 are also located on the top or the bottom. Okay, that's the difference. And with the Fronius Smart Meter, the old one, your settings are by 2 buttons, and whereas with the Smart Meter TS, the settings are done by the touch screen display. Okay, so with the old Fronius Smart Meter, in order to go to any new screen, you have to use those 2 buttons, okay, to toggle. Whereas with the new Smart Meter, it's completely touchscreen. Okay, so it provides a much better user interface. The old Smart Meter, the dimensions was 4 DU, that's for 4 by 18 millimeters, whereas the new one is 3 DU, and that stands for 3 by 18 millimeters. We will now move on to the installation of the single and 3-phase Fronius Smart Meter TS meters. With the first 65 amp 3-phase Fronius Smart Meter, the cabling will look as follows. You will have L1, L2, and L3, okay, coming in on the top of the smart meter. Okay, you will then have L1, L2, L3, then exiting on the bottom of the smart meter. Okay, this is for the 3-phase 65 amp smart meter. Okay, your feeding point, your neutral, will be across those terminals, and you will then have a 315 milliamp suggested fuse from your neutral to the neutral port on the smart meter. In terms of the connection of the smart meter to the Fronius inverter, in this scenario, I have the new Fronius Gen 24 inverter, okay? And this is how the connections will look with the Smart Meter TS. So what I have indicated over here on the right-hand side, I have taken a screenshot of the pilot, which is the communication card in the Fronius Gen 24 Plus hybrid inverter. And I have taken a screenshot of the RS485 connection points on the Smart Meter TS. Okay, so that's what we have on the left. And on the right is we have the pilot connections. Okay, so as you can see, it's pretty straightforward. It's the RS485 connection cable. Okay, port 10, that's the ground connection of the RS485. Okay, port 9, that's your negative. Okay, and then port 8, okay, that's going to be your positive for data communication. Okay, then your pilot will basically be connecting across the respective 3 ports on the right-hand side. Okay, so across V+, M0+, and your shield. Okay, in terms of the termination resistor, if you are using a Fronius Gen 24 Plus inverter with a pilot installed, the termination resistor will be in the form of a switch. Okay, so you'll just switch between those 2 positions in order to switch the 120 ohm resistor on or off. Okay, in terms of the actual smart meter, okay, this will occur by bridging on the smart meter between port 7 and port 9. Okay, if we look at the cabling of the smart meter TS with the Fronius snap inverter series range, you have seen that I've indicated a Fronius Datamanager on the bottom right, and I also have indicated a Fronius Smart Meter TS on the left. Okay, with the Datamanager and the Fronius Smart Meter TS, the connection occurs via RS485 connection as well. Basically, port 8 is going to be your D plus connection, port 9 will be your D minus connection, and port 10 will be your ground connection. Okay, so that's how the connection will occur between the Datamanager and the Fronius Smart Meter TS. As you can see, your neutral is in the exact same position as the previous slide, and L1 and L2 and L3 are also in the same position. Remember, for the 65 amp three-phase smart meter, you do not need to use an external CT, so you can directly connect your line connections directly to the smart meter, okay, without having to step down the current. Okay, for the 120 ohm resistor on the Datamanager, that also occurs in the form of a switch, okay, and then you just got to make sure that you bridge port 7 and port 9 on the smart meter. Okay, the difference here is with the smart meter TS and the old smart meter. With the old smart meter, you have to use a physical 120 ohm resistor, whereas in this scenario, you can just bridge it with a wire, and you will be able to get your 120 ohm resistance. Okay, now moving on to the three-phase 100 amp single phase smart meter TS. In my opinion, this has a lot of advantages on the market compared to the old 63 amp single phase smart meter. The reason for this is in Africa, there is a lot of residential households that can exceed 63 amps on the single phase. Okay, that's why it's very important that we actually bring in a bigger smart meter to the market, and this is why the 100 amp smart meter will definitely be beneficial to the African market. Okay, with the 100 amp smart meter, if you look at the top, this is where your L in will come in, and that's where your L out will be. Okay, your neutral port is going to be over there. Okay, in terms of the connection to the pilot, which is the communication card in the Gen 24 Plus hybrid inverter, it will be the exact same as with the previous slides as I showed you. Communication occurs via RS485 connection. Okay, port 3, 4, and 5 will be the communication ports. So port 4, 5, and 6 will be the communication ports. Port 6 will be the ground connection. Port 5 will be the negative port, and port 4 will be the positive data communication ports. Okay, and that will exactly tie in with the Modbus RTU connection points on the pilot card. Okay, now moving on to the biggest new smart meter from Fronius, that will be the 5 kiloamp three-phase smart meter. With this smart meter, it's very important to note that you do have to use external CTs, okay, and so that is a non-negotiable. And with in terms of the fuses, it is suggested that you do have a 315 milliamp fuse on neutral, L1, L2, and L3. Okay. And it's also suggested that you do have a 315 milliamp fuse on your neutral and L1 at the bottom of the smart meter as well. In terms of the communication ports, it will occur via RS485 connection once again to the Fronius pilot card. Okay, so the communication is via Modbus RTU once again. We will now move on to the next part of the presentation, which where we will be discussing the energy profiling. So with Fronius smart meters, what's very good about them is that you can use more than one Fronius smart meter in a system. The maximum amount of Fronius smart meters you can use in the system is 4 Fronius smart meters. Okay, so in this scenario, I have one primary Fronius smart meter, and this primary meter, its main focus is to basically measure what's going to the grid and what's coming from the grid, and also to set any zero feed-in limitations. So if you are in a municipality that has zero feed-in limitations, okay, or that has partial feed-in limitations, you can change the feed-in limit on the Fronius smart meter from 0 to 100%, in order to control how much excess power you are sending to the grid. Okay, but in order to do this, you need to install the Fronius smart meter in combination with the Fronius snap inverter. You can also install secondary meters, and this is very useful if you do want to do energy profiling. So you can install a maximum of 3 secondary meters in a Fronius system. And the core task of a secondary smart meter is to basically do energy profiling. So in this scenario, I have a heat pump, which is a very big load, and it can be very important to monitor how much this load actually pulls throughout the day. Okay, if you also have another integrated small scale embedded generation in your PV system, such as a wind turbine, this could become useful. As you know, it's not advisable to feed in power from a PV inverter to a wind turbine, as this can damage the power electronics in your wind turbine. Okay, hence it's very important to install a secondary Fronius smart meter in order to set in a feed-in limitation, in order to prevent any power from going to your embedded generator. Another extremely useful case would be a pool pump. With a pool pump, it is a very big consumer as well, and it can be very important in order to monitor how much this pool pump is pulling throughout the day, and in order to draw up consumption curves for this pool pump throughout the day. Okay, just remember you can only have one primary smart meter in a system. Okay, you cannot have more than one Fronius primary smart meter in a system. Okay, if you have any questions on the content that I have presented so far, please feel free to post your questions in the question tab on software, and my colleague David will be attending to those questions. I will now be moving on to the Fronius Sensor Card. With the Fronius Sensor Card, it either comes in a card version or it comes in a box version. What I have displayed on the screen at the moment is the card version. Okay, so with the card version, you can mount it internally in the Fronius inverter. If you do purchase the box version, you do mount it externally. Both have the same core task, and that is to connect different sensors. Basically, the sensor card will connect the data from all the sensors and then send this data to the Datamanager card, which will then transmit all this data to Solarweb, where you can then view all this data online. You can connect up to 10 sensor boxes in a system or sensor cards. And as I alluded to earlier on, you can get this in a card version or a box version. You can connect different sensors to the sensor card. Okay. The type of different sensors you can connect is what I've displayed to you on the screen. You can obtain all these different sensors directly from Fronius. Okay, so the first sensor on the top left, that's a voltage sensitive input for irradiation. Sorry, that's the top right. Okay, what I have on the top left, that's your temperature input. That's a PT1000 temperature sensor. Okay, what I have then on the bottom left of the screen, that's a wind sensor. Okay, and what I have on the bottom right of the screen is a surface temperature sensor, such as a module surface temperature sensor. Okay, so using these 4 different types of sensors, you can get a very good overview of the PV system, and you can obviously obtain the ambient temperature, which will be obtained via the PT1000 sensor. Your module temperature of the PV modules will be obtained via the surface mount temperature sensor. The irradiation from the sun can be obtained via the irradiation sensor, and the wind, which could be very useful in order to determine whether your PV modules can be cooled efficiently, would be your wind sensor. Okay, these sensors will basically submit all their data to the sensor card, and the sensor card will then submit all the data to the data manager, and the data manager will then send all this information to Solarweb. Okay, you can then log onto Solarweb, and then you can then remotely access all the data from your sensors on Solarweb. Okay, so in this case, this is actually a screenshot of one of our sites in Italy, whereby we have a temperature sensor, we have a module sensor as well, temperature sensor, and we also have an irradiation sensor installed on site. Okay, these results were taken at 20 to 8 in the morning, and this was around winter time in Italy. As you can see, at 20 to 8 in the morning, your ambient temperature will almost match your PV module temperature. Okay, so they were both 15 degrees Celsius, and the irradiation at this time of the morning was extremely low at 193 watts per meter squared. And using Fronius Solar.web, we can basically plot a graph for the day. Okay, so as you can see throughout the day, if you approach 12 o'clock, between 12 and 1, that's where your max irradiation occurs. And as you can see, as we go later down throughout the day, the irradiation will then decrease. As you can see, the sun sits pretty late, it's at about after 6 p.m. I'll now be discussing about the Fronius Datamanager, just to give you a very brief overview. The Fronius Datamanager is basically the integrated communication card found in Fronius snap inverters. Okay, you get two versions of Fronius snap inverters. You get the Fronius snap inverter Lite, and then you get the Fronius snap inverter, which has an integrated data manager inside already. In order to pick whether a Fronius inverter has a data manager or not, is to see the naming of the Fronius snap inverter. If the Fronius snap inverter has Lite at the end, it means that the data manager is not integrated. You've got to buy it separately. If the Fronius snap inverter does not have Lite at the end, it means that the data manager is integrated. With the Fronius Data Manager, it is a plug-in card. It includes a data logger, a web server, and a Wi-Fi card, all integrated within the data manager itself. Okay, that's an old screenshot of how the data manager looks. We can get it in the card version, which is basically a retrofit kit inside the snap inverter. Or you can get it as the box version, which is an externally powered box. You can monitor up to 100 inverters with the one data manager. So if you are doing a very big commercial installation with, let's say, more than 20 inverters or 10 inverters, you only really need to get one data manager. Okay. With the data manager, it will collect all the information from the snap inverters, and it will then transmit this information to our Solarweb portal, to our Solarweb app, as well as to Fronius Solar.tv web-based user interface. It has various open interfaces, such as Modbus TCP, that's for your Ethernet connection. It also has your Modbus RTU Sunspect for any RS485 communications. It also includes your Fronius Solar API, which is your internal Fronius communication language. It also includes ports for the Fronius smart meter via the RS485 connection points. It also includes energy management outputs. So you can basically connect up to 4 external relays to the Fronius Data Manager, and when a certain power threshold is reached, those relays can now be triggered. If you look at a Fronius snap inverter, if you take off the front cover of the Fronius snap inverter, the DACM cover, you will basically reveal the communication links on the Fronius snap inverter. If you look at the left link, that is called the reservoir card. Okay, so the part that I am circling now, that's the reservoir card, and that's basically the communication card of a Fronius snap inverter. Under each reservoir card, what's very important to note is port 9, which is your signal inputs. And the signal inputs could be to an external alarm. Okay, so you can trigger an alarm to go off when, for example, a certain power threshold is reached. Port 1 and port 2, that's your Fronius Solar Net in and out communication ports. Okay, and that's for your Fronius internal communication. Okay, so if you have more than one Fronius inverter, okay, so let's say if you have 3 Fronius inverters, you'll basically go from the out of the one Fronius inverter with a Cat5 connection to the in of the next Fronius inverter Solar Net in communication ports. You then have port 4, which is your potential for free relays. Okay, you also have port 5. Okay, so port 5, we basically now move on to the data manager card. So from port 5 to port 8, so what I am circling now, that is what we call the data manager card. Okay, so in the Fronius inverter, there's 2 sort of communication cards. There's the first one called the reservoir card, and the second one called the data manager card. The reservoir card comes standard in all Fronius inverters, snap inverters, and the data manager card can come as an optional extra in Fronius snap inverters. Okay, so port 5 of the data manager card is your wireless LAN antenna. Okay, that allows for wireless connection to a router. Port 6 is your digital input outputs. Okay, and that's for a Modbus RTU connection. Port 7 is your Ethernet connection, and that's for any Modbus TCP connections. Port 8, those are your status LEDs, okay? And these will indicate different online connection states of your Fronius snap inverter. Okay, I have now zoomed in to the previous picture, okay? And just to give you a clearer picture of the different connection points on the two cards found inside a Fronius snap inverter. As I alluded to in the previous slide, port 1 to port 4, that's included in the reservoir card, okay? And as I said earlier on, that is a standard, that's a standard card from a Fronius snap inverter. Okay, so just what's important to note again is that port 1, that is again for any external triggers, which could be a trigger coming from a energy meter, okay, such as the overvoltage protection, okay. And port 2 and port 2, that's going to be your connection points for SolarNet, so to communicate with another Fronius inverter. Port 3 is going to be a USB interface, and that could be for USB logging, but it can also be used for any USB updates. What's very important, if you are going to be doing USB logging, please make sure that you insert a USB into the inverter before you start the logging. Okay, so you can't go to sites and then install a USB to get past history. That is not possible. The USB has to be installed inside the inverter from day one in order to get logging from day one onwards. Okay, port 4, that's going to be a configurable potential free contact. And, this again can be used for energy management. Okay, so it can be connected to a power meter as an example, or it could be connected to any signal relays. Port 5 is your configurable input-output ports, and this is for any Modbus RTU connection points. An example of which could be for the Fronius smart meter, or it could be for external relays as well. If your grid utility does require to control or throttle down your Fronius snap inverter, this is where you will now connect the grid utility points to the Modbus RTU on the orange plug. Okay, port 6 is your Ethernet connection, and this can be used for connection to your local area network, or it can also be used for JSON, or it can also be used for Modbus TCP connection points. For example, if you are going to do an AC coupled connection with a inverter charger, it's very important that the inverter charger can throttle down the Fronius snap inverter. You can do it in one or two methods. The first method is via Modbus RTU, and the second method is via Modbus TCP on the Ethernet connection points. Okay, I'm now zooming into the Fronius Datamanager. What you can see is your wireless local area network antenna. Okay. You can then see your Modbus termination switch. Okay. And for Modbus termination switch, you get position A or position B. Okay. One of the positions gives you an assigned IP address, whereas the other position gives you a predetermined IP address. Okay, the orange plug, this is where your input and output terminal ports are. Okay, and I have zoomed into it, and I have alluded the legend at the bottom of the orange plug. As you can see, this is where RS485 communication link will be. So if you are connecting a Fronius smart meter, for example, it will be on the D+, D-, and D-. If you are going to connect relays, it will occur from port 0 to port 3. And then port 4 to port 9 can be for any external power limitation signals that can throttle down the Fronius inverter, as an example. Okay, that's going to be your LAN Modbus TCP connection point via Ethernet connection. And then the next port is going to be an IP switch. Okay, and that will pretty much toggle between position A and position B, which will basically give you a predetermined IP address, or it will give you a assigned IP address. So I think I made a bit of a hiccup at the beginning where I did mention that that was the Modbus termination switch, and that was incorrect. So this termination switch over here will either switch on the 120 ohm resistor or switch it off. Okay, so that's what that switch will do. And the IP switch will basically toggle between an assigned IP address and a predetermined IP address. So just please note that on the Fronius Datamanager, you do get two switches, and you also get a third switch, which you can't really see in this picture, but the third switch will basically switch on the Datamanager or switch it off. Okay, these LEDs will basically display your different connection statuses. So they can basically display whether you are connected to a wireless local area network successfully, whether you are doing the correct supply, or even whether you are correctly connected to Solarweb. Okay, I'll now be handing over to my colleague, David Mwangi, who will be taking over from the rest of the presentation. And I will be in the background answering any answers that will be asked from the audience.
So thank you so much, Mohammed, for that very nice first part of the presentation. I will now be taking you through our second part of the presentation, where we'll be talking about starting with the data manager commissioning process. What I'd like to highlight here is that the reason we are talking about all these devices is because our focus today is the monitoring options available from Fronius. So for you to be able to monitor your system, you must be able to configure and install these devices that we are discussing. And so far, we've already discussed the smart meter, which is giving you an overview of your consumption and production data. We've looked at the sensor card for weather management, and now we are going into the Fronius Datamanager card. What I would like to add here is that the Fronius Datamanager card is actually the heart of your communication into the monitoring platform. That means that the data manager card is the one responsible for sending all the system data that is collected within your system to Solarweb for monitoring. So to commission the data manager, we have two ways that you can do this. The first one is what we call the easy startup. And this is basically happening when you connect your smart device to the Wi-Fi access point of the inverter. Then you put in your smart device, you open the web browser, preferably Google Chrome, and you put in this IP address here. This IP address is the same for all Fronius inverters or Fronius wireless access points. Once you do this with the easy startup, then your setup wizard will automatically start. The next way to do the commissioning of the data manager is through the normal procedure where you activate in the setup. When you go to the display of the inverter, the snap inverter, you go to the setup section of the inverter and you activate the wireless Wi-Fi access point. So once you access that, you will see the ID of the wireless that you are accessing, and it will be Fronius 239-, and this number here is actually a representation of the data manager ID for that particular inverter. Then you of course enter the default password, which you can see here, and then enter the same IP address as I had mentioned before. That is 192.168 up to 1.81, and then the setup wizard will start up. So when the setup wizard startups, so with the WPS function, you are also able to automatically connect your inverter to the wireless internet, and therefore continue with your configuration. For a more detailed look into how the data manager is being commissioned, please visit YouTube, and on this link you're going to get a very clear illustration on how to commission the data manager card. Next, let's look at the Fronius Solar.net ring. And as I've mentioned, we need to be able to configure our devices for proper monitoring. If you have, for instance, an installation with more than one inverter, all those inverters must be able to communicate to one another. So in the first example here at the very top, we are looking at light versions of our inverters. So a light version means basically an inverter that has no data manager card inbuilt. So in this case, we have what is called a data manager box in the outside of the communication ring. So all the inverters are connected through the Cat5 in and out topology, which is a daisy chain, and they are all communicating to the data manager on the outside. What I should add here is that when you have a data manager on the outside of the inverters as a data manager box, then you need to include also a separate DC power supply for this data manager box. Another example is when you have an inverter with an inbuilt data manager card, and therefore the other inverters are looping or connecting to the first inverter to communicate their data as requested by the data manager card. What you can note in these two examples is the fact that we are using the termination plugs from on the first device and the very last device. And also similarly, in this other example, we are also using a termination plug in the first and last device. So the termination plug is telling the communication loop that this is the head of that ring. So once it gets to this termination plug, then no more requests are pushed forward from that point, and therefore all the data has to go back to the starting point. In terms of the cable inlet, it's very important to ensure that for the inverter to maintain the IP, the rated IP or ingress protection rating of IP65 for most of the SNAP inverters and IP66 for the Gen 24 inverters, that you fit in the cable guard properly once you have put in your data communication for port 1 and 2 for the solenoid ring. So you can see here number 1 and 2 that are going into what my colleague before called the reservoir. And the reservoir is also part of the display of the SNAP inverter series. For you to be able to communicate your data into Solarweb using the data manager card, this can happen in two ways. One way would be that each of the inverters installed is communicating wirelessly into the wireless router and then feeding your data into Solarweb for monitoring. And of course, the monitoring platform, which is Solarweb, is available for all smart devices. It can be done on your tablets, your laptop, or any smart device, including Android watches and so forth. The next variation is where you have one inverter here with a data manager card, and therefore this is your web server in this inverter. And then all the other inverters connected to or in your system could be up to 100 inverters or so. Then, as my colleague has mentioned, we recommend that you divide every 20 inverters to connect to one data manager. And therefore, each constellation of 20 inverters here could be connected to one inverter with a data manager. And these are either feeding through a LAN cable or a Wi-Fi network into your router, and then transmitting this data into Solarweb similarly for monitoring. Going further, let's look now at energy management, because when you go to Solarweb, energy management becomes part of the reason why you need to have a monitoring platform, because you can see if there is any potential for you to make use of excess energy in your system. So for you to be able to monitor or to make use of the excess energy, of course, you require a smart meter. My colleague has already talked about how to commission and install the smart meter. So the smart meter is basically checking at the feeding point what is the surplus energy available. So if you have any surplus energy available, then you can decide if you want to include other loads through the digital inputs and outputs for you to be able to activate other external loads. The digital outputs on the data manager, I think, have already been covered. If you have an older version of the data manager, or if your system was installed a couple of years back, you need to do a software update for that particular data manager for you to do the digital loads management. And of course, the loads can be anything from a pool pump, air conditioning, and so forth, or even charging of an electric vehicle. So anytime you have excess energy through the digital IOs, then you can choose, depending on the threshold which you are going to look at next, at which point you want to activate which load. So when you go to the web interface settings of your web setup wizard, then you go to the section that says IO mapping. Then in IO mapping, you can activate this position 0 to 3. So those are 4 positions. And these positions are basically limited. Also, if you are talking about how many smart meters you can have in a system, you can have a maximum of 4 because the Modbus addresses is limited to 4 in the data manager card. So, but depending on the availability of excess energy, you can configure the loads or the relays to activate based on priority. So load 1 could have a lower threshold of starting, then the next load depending on the next portion of excess energy available, and so forth. Yeah, so, and this is this particular example. So for instance, this is a pool pump that we have designated a feed-in of about 1,200 watts. And you can also decide the minimum duration that this load has to run and the maximum duration per day. So these are all flexible settings that you can choose in the data manager. In the next 2 possibilities, we have also assigned 2 other loads that can activate accordingly depending on the excess energy available, as I had said before. And once you have all this data available, then you come into now Solarweb, and you're going to be able to monitor all your data and see if there are any possibilities of improving your system. So before we go on, I would like to launch a poll just to get an idea of how familiar you are with our monitoring devices. So the poll is, which Fronius monitoring devices are you familiar with? So kindly give us your feedback. We would like to see how familiar you are with our devices, so that if you have any particular questions or needs that need to be addressed, then we can figure out how much in terms of information we should be giving you for the concerned device. So I will leave on the poll for the next 20 seconds or so. And then after that, I will be sharing the results with you. So kindly take your time and give us your feedback. Is very much appreciated. Okay, so I see quite a good number of you have already voted. So I'll be closing in the next 5 seconds, and then share the results with you. Okay, so as you can see, quite a good number of our attendees today are familiar with the Data Manager card, and that's very good because, as I said, the Data Manager card is actually the central part of the monitoring platform, because without data being sent to the monitoring platform, then you have no data in Solarweb for you to monitor. The smart meter and the sensor card all have to go through the Data Manager card to be able to see their data in Solarweb. Out of all those who are attending today, none of them really have experience with the sensor card, and we will be covering the sensor card in a later training. So kindly keep on the look for this one and register for this training when it's available. So let's continue with the Fronius Solarweb. So as I mentioned before, Fronius Solarweb is now the monitoring platform. So, and the reason you are able to monitor your data is because you've done your configuration and commissioning of the data manager to start with. And now the data manager, communicating either through Wi-Fi or a cabled connection to your router, is able to send your system data through the internet to Solarweb for monitoring. Of course, as I mentioned before, all smart devices can have access to the Solarweb monitoring portal. So depending on which device you're using, whether a phone, a tablet, or a watch, then you can go to the applicable app store for your device and download the relevant version of Solarweb for monitoring. In terms of accounts, there are 3 basic ways to access Solarweb. Number 1 is what we call the free version of Solarweb, which is will always be free. And in this account, which is free, you get basic system data for the last 3 days. And then you have a premium version of the Solarweb account where you get more detailed personal reports, including performance graphs. And you have also access to all archive data for your system. And this is not limited. You can go as back as even 10 years with this archive data when you have a premium account. That notwithstanding, if you are a completely new installer with no experience with Solarweb, or you have no system running that you can say, I have an account that I can create for this system, we have a demo account within Solarweb where you can see quite a number of active systems and then be able to interact with Solarweb to see how it fits into the operation and monitoring platform. So simply going to your web browser and typing this address here, that is www.solarweb.com, you're able to access the Solarweb platform, and here you can access a demo system for you to view. When you go to Solarweb proper, then you can see this kind of information displayed. So in this kind of system, for instance, we can see that we have a production of about 2.85 kilowatts. This is your solar PV. And you can see here the solid color is showing you the percentage of production. So this is just about half of the installed capacity of this system. And you have another bigger portion here that is not being utilized or is not producing power for you at this moment. And this could be because of overcast conditions or things like that. But by clicking any of these charts in Solarweb, you're able to get such a detailed overview. In this particular screenshot, what we can see here is that the battery was being charged with 2.28 kilowatts of your PV production and the state of your charge of the battery. In some instances, of course, you don't have a battery in the system, so the distribution will be between your PV production, consumption, as well as what is being fed into the grid, if you have permission to feed into the grid, or what is being taken from the grid. And in this case, we are taking about 6 watts from the grid. Going further, let's look at the system management in Solarweb. So as I've mentioned, you can create just one account for your systems. And if you have, let's say, a premium account with several systems, you do not need a separate account for each of the systems that you have installed. So in this case, you will require only one account, and you'll have a dashboard with all the systems that you have installed. And you can switch from a widget for each system with a photo of each system to a list view of the systems installed. Additionally, you can export this data in CSV format into your laptop or computer for monitoring. So error messaging can also be done. As you know, the Fronius inverters are from time to time sending you state codes, and you are able to get an email depending on the frequency of the state codes. In addition, you can compare the production. If you have more than one inverter in the system, you can compare the production from one inverter to the next. And if, for instance, the orientation of the modules or the solar panels is the same, you are able to identify if one inverter has an issue because it's underperforming. So Solarweb becomes a very important part of your fault diagnosis. In addition, you can do comparison at MPPT level. So in this graph here, when you look at the production, hoping you can see the figures. So you have one part of the curve here that is in red, yeah, and then another one in blue here. So these are the production from the 2 MPPTs, because for all Fronius Snap inverters except the Echo, we supply them with 2 MPPTs, and therefore you are able to compare each MPPT and see what is the performance, and then the two will give you an aggregate of the total of the production from that particular inverter from those 2 MPPTs. And in this case, we can see they are nearly balanced at 8 point something, giving us a total of 16.92 kilowatts. And this is an example of a SIMO 20 inverter here. What else you can see is the possibility to do a remote software update for your system. So if you require to do an update of your system, or updates are actually available, all you need to do is to go to Solarweb, and you can see a list of your components that are installed for that particular system or installation, and you can see right away if there is any available update. So all you need to do is to activate the update remotely. The only condition is that the inverter must have a very good internet connection for the update to complete. Going further, let's look at also another illustration here of how your sensor card data will look in Solarweb. So you can see what were the values for the ambient temperature, what was the value for the module temperature, as well as average irradiation. So at this particular moment, 7:40 in the morning, we have about 193 watt per meter squared, and then the irradiation is plotted throughout the day until the sun has set. So, and this data from the sensor card is actually quite useful because it can help you to do what we call performance ratio comparison for all your installed systems. Let's proceed and look at also the Solar TV, which is also another possibility for monitoring your devices. So other than just going to Solarweb, you can have a Solar TV installed right in the comfort of your office or the front area of your office, where you can see critical data from your system. And this can be either daily data, monthly, or 7 days data. So in this particular case, we are looking at a screenshot that has data for the last 30 days. So you can see how your system is behaving. And then here you can also see the carbon saving and stuff like that, and the total utilization of your system. And this is a very nice and sort of nice way to captivate your customers when they visit your offices, to see some selected sites that are already working for you and using a very good monitoring platform from Fronius. The other key function of Solarweb, other than just monitoring your devices, is that it allows you to register for warranty extensions. As you may know, the standard Fronius warranty, depending on your market, is 2 years warranty when you get the products shipped to you. But you have the possibility to extend the warranty to 5 years or up to 15 years, depending on requirement. And this has to be done within the Solarweb platform, where you go to register product and then you fill in the requested details. And then if you require an extension of warranty, you basically go to Solarweb shop, where you can extend the warranty by purchasing. So when you purchase a 5-year warranty extension, you will get a zero figure invoice. So that does not mean you're paying us anything. It's just an invoice that needs to be produced from the web shop. And after that, you can basically print a PDF certificate of that warranty extension for your device. Another key function of the Solarweb monitoring portal is the fact that it has a solar configurator tool embedded, and this basically allows you to design your system optimally. As you know, we have recommendations on the string lengths, what is the maximum allowable voltage on the DC side to be connected to the snap inverters. And therefore, using the solar configurator, you're able to determine if your design is within those limits. So when you visit Solarweb, which I would like to quickly show it to you, you will come to this section. Once you type in the Solarweb.com, and then you will see the solar configurator, which you can basically start up. And when you start the solar configurator, you are able to input a lot of your data into the system, depending on the particular system design. And yeah, so this is the dashboard, so to speak, of the solar configurator, which is your design tool provided for free by Fronius. So even when you don't have an active account with Fronius, you can go to the Solarweb platform by typing Solarweb.com, and you access this solar configurator free of charge. And as you're going to see next, there are quite a number of things that you can be able to design using the solar configurator. And number one, you can look at the module requirements or the specifications. We have quite a number of module manufacturers who are listed in solar configurator with models, and here you also can specify what is the number of modules you're working with, as well as the module temperature. We have all the Fronius inverters already integrated, and depending on your country where you want to install the system, then the configurator can also recommend which inverters are ideal for your particular market. And lastly, we also have the possibility to integrate storage in the general area of the solar configurator, as we see next. So basically the module, as I've said, you can select here quite a number of module manufacturers, and then the exact series of the module that you're going to use, and you can specify also here the number of modules that you want to integrate into the system. The moment you enter the number of modules, then the system automatically works out for you what is the installed kilowatt peak for that particular selection. Lastly, you have to specify what are the temperature ranges that you're going to work with, the minimum temperature and the maximum temperature. This is important for the solar configurator tool to be able to know what are the expected maximum and minimum open circuit voltages of your panels, and to check if these are within the limits of the recommended connection of voltage on the DC side to the snap inverters. Next, we look at the inverter selection. As I've mentioned before, depending on your country where you want to install the system, then you basically have to choose a country here, and all the available inverters or recommended inverters for your country will be available for selection as well. And then you specify what is the inverter ratio, meaning also here you have the possibility to say or for the system to determine out of your selected PV module connection, what are the ratios in terms of the maximum connected PV power and the maximum connected PV power. As you know, with all Fronius inverters, especially the snap inverter series, there is the possibility to oversize your system with up to 200% in some cases for the Primo series of inverters. And what I'd like to mention here is that our upcoming Gen 24 inverter, which is the hybrid version of our snap inverters, is fully integrated now into the solar configurator. Going further, we look at the general area of the solar configurator, where basically this allows you to enter your project name, decide or choose whether your system has battery storage included or not, and then what is your projected annual power consumption, and then what is your user profile. So user profile here says employed or family. So when the system says employed, it basically means that a lot of your available PV is not fully utilized during the day, and therefore if you integrated a storage system, then you're able to make use of your PV energy that will produce during the day at night from your storage. And then if you have a family setup, it means you do not have too much available energy for storage, because a lot of your activities probably are happening during the day, and maybe a lot of your family is at home during the day. So you are making nearly 100% utilization of the available PV energy. So that brings us to the area where we want to look at how you can get support from Fronius. And at Fronius, we pay very particular emphasis on support, after sales support especially, because this is what ensures the success of our products. So we offer support in key three ways. Number one is through the Fronius system partners. And system partners basically include all our installers. Then you have what we call the distributors or sales partners. And with these partners, we are continually giving them expert knowledge on all our products. And when you go to fronius.com, you can also find the nearest Fronius service partner nearest to you. In addition to that, we also have our technical sales advisors like myself and my colleague Mohammed that are locally available, also in the regionally, to interact with all our partners and to give them support on any required aspects of our products, whether it's design or product knowledge or troubleshooting and stuff like that. But for troubleshooting proper, we have a key department within Fronius Solar Energy Unit, that is the Tech Support International. So we also have a hotline where if you encounter problems on site that you're not able to solve, then you're able to call in and discuss what needs to be done with our experts at Tech Support International. And therefore, you get very customized and individual help for any challenges that you encounter with your products. Lastly, if you require any specific information, you can get in touch with any of us. The numbers are shown here on the screen. Unfortunately, our colleague Cyprian was not able to join us today, but still, for the West African region, you can still get in touch with Cyprian and share with him any challenges that you'll be encountering. So that brings us to the end of our presentation today. But we will be doing a brief question and answer session with my colleague, Mohammed. So please stay online for the next couple of minutes, and we will share some of the most frequently asked questions with you. So I think, yeah. So Mohammed,